Now, the third type of probability that we're going to look at is theoretical probability. Now, this is based on the mathematical laws of probability, and it only applies to situations that can be modeled by mathematically fair objects or experiments. And as an example, we're going to take a look at rolling a single die. And if we take a look at this die, and if it's not loaded, then every time we roll the dice, then each number on the six-sided die has an equal likelihood of coming up. So from one roll to another, you're as equally likely to get a 5 as you are a 4, etc. So if we take a look at what how to calculate the probability of any one event occurring, then we use the formula PA, which is the probability that A occurs, is equal to the number of times where A can occur, or the number of ways that A can occur, divided by the total number of possible outcomes. And we can illustrate this by looking at a few easy examples. For example, if you want to know what the probability of rolling a 1 is, well, when you roll a single die, there is one favorable outcome, and that's if you roll a 1. There are 6 possible outcomes because there are 6 possible rolls on a single die. So the probability of rolling a 1 is 1 over 6. So here, the number of ways you can have a 1 is 1, and the number of possible outcomes is 6. Now, the probability of rolling a 2 or a 1, in this case, the number of ways that you can roll a 1 or a 2 is 2. So you could either roll a 1 or a 2. Now, the probability then would be 2 over 6, because our sample space is still 6. So this is 1/3. In other words, you have a 1/3 probability of rolling a die and it coming up with 1 or 2. And that's theoretical. Now, if you want to know what the probability of rolling an even number is, well, that's the probability of rolling a 2, a 4, a 6, and there are 3 ways that you can do that. So the number of favorable outcomes is 3 over the total number of outcomes is 6, which is 1/2. So that we have a 1/2 probability, or a 50% chance, of rolling a 1. Rolling an even. So moving on, if we take a look at this spinner, and I ask the question, what's the theoretical probability of the spinner landing on red? Well, it's a fair spinner. So if I start the spinner, it is equally likely to land on any of the four colors. So here, the theoretical probability is going to be one favorable event over 4 possible outcomes. So the answer then is 1 over 4, or 25%. So the theoretical probability of the spinner landing on red is 25%. Now, if we take a look at a situation where we flip 10 coins, and we're interested in how many times heads will come up. Well, the theoretical probability of flipping a coin and getting a head is, there is one possibility it lands heads over 2 possible outcomes. You could either get heads or tails. So when we ask the question, if you flip the coin 10 times, how many heads would you expect to get? Well, in this case, we're going to calculate the expected value, or the expected number of heads. It would be the number of trials, n, times the theoretical probability of that event. So the expected value here is going to be 10 trials times 0.5, which is 1/2 or 50%. So the expected value is 5. So now if we take a look at a few questions, if you flip a coin, the theoretical probability of getting heads is 1, because there's 1 possibility, over 2. We just covered that. The theoretical probability of getting tails will also be 1 over 2. If you roll a die, the theoretical probability of rolling a 1, well here there's 1 possible outcome and 6 total possible outcomes. And if you draw a card from a deck of cards, the theoretical probability of drawing an ace. Now, in a deck of cards, there are 52 cards, so that's our total sample space. And the number of aces in a standard deck of cards is 4. There's 1 for each suit. So the probability of drawing an ace will be 4 over 52, which is equal to 1 over 13. Now, I want to cover complementary events. So the complement of a set A is written as A prime. And it consists of all the outcomes in the sample space that are not A. For example, rolling 1 die, the sample space is 1 through 6. If event A is rolling a 4, then the probability of rolling a 4 is 1 over 6. That means that the complementary event, so this means that the probability of not getting a 4, that means you get a 1, 2, 3, a 5, or a 6. There are 5 possible outcomes and 6 total possible outcomes. Then you'll notice that 1 minus 1 over 6, which is 1 minus the probability of A. So I'll write this out. So 1 minus 1 over 6 is equal to 5 over 6. And a couple of other things here. So the minimum value for any probability is 0. Means it's impossible, won't happen. The maximum value for any probability is 1, which means it's certain. So we can express probability as a ratio, a decimal, or a percent.